I'd like to briefly explain the process or the algorithm behind reversing a linked list. And if you're not familiar with what a linked list is, it's essentially just a bunch of objects, their locations in memory, that are essentially scattered about. And each object essentially contains a value. And these values are essentially in a random order. And so in order to determine what the next value is in line, each object also contains a reference. And these references actually link one value to the other, or one object or one location in memory to the other. So this particular object would have an ID, and that ID would essentially be of the location of the next object. It would be the ID of the next object in line. So it's essentially just a bunch of objects in memory that contain values, but they also contain references to the next object that essentially comes from the reference that it contains. So the basic idea here is that, this reference essentially points here, this reference points here, and the last reference will point to null. It's not going to actually have any further reference because there aren't any further objects. So that's the basic idea behind a linked list. And this assignment in particular is to reverse the order of the references. But one thing that I want to clear up is when you have an object, often you hear it referred to as node. It's not actually a node. The node is but the reference that refers to the object or to the location in memory that holds the value and the reference to the next object. So if I create a node X, node X is not the object itself. Node X is but a reference to the object which contains the value. So you have to filter through the reference in order to get to the actual object. So that distinction is pretty important. So when I create a node class, a template, a blueprint that is further going to create node objects, I could have, let's say, an int value for the object, and I could also have a reference. So I'll have a node, and I'll call it next, which will contain the next. It will contain the ID of the next node in line. And so when I create the node object, when I say node node 1 equals new node, I'm not really creating a actual node here. I'm creating node 1 is a reference to a location in memory that contains this value and a reference. So that's sort of important to make a distinction with to essentially prevent further confusion. But back to the original assignment, we essentially have a linked list or a bunch of these objects, and the reference is in a linear manner. And we essentially want to reverse these references. We don't want to reverse the nodes. We don't want to take this guy's value and put it in this guy's value. We essentially just want to reverse the references where one object is pointing to the other. So if this object right now is pointing to this guy, we essentially want to withdraw the reference and have it point in the opposite direction. And the same would go with this guy here. This object is pointing to the next object in line. We want it to point to null. And so our linked list in total would look like this after we iteratively reverse each reference of each object to the next, or really each node, but as it's called at least. So what we do is we begin by having a method which often takes in it often takes a head variable, and I'll bring that now. And the head is actually just the head of the linked list. So it's essentially the this would be considered the head, and this would be considered the tail, given as it stands right now. But we're obviously going to change that process. So given the head, the method expects you to be able to reverse the linked list. We begin by having a reference. We create a reference called current, which I guess we're calling cur to keep it short. But so you create a reference, which I said is just a node. The node is the reference to the object, and it's called current. And we'll essentially set it equal to the head. And that's how we get current referencing this guy here. And we then, of course, start by having another reference, and that's essentially going to be called previous. And that, as of for now at least, it's going to be set to null. And the idea there is that we create a reference, and it's called previous, and it's set to null. So this is how our situation would look right now. And then we create a while loop. So the while loop is essentially going to iterate through the entire linked list until the current value or the current reference or what the current is referencing is not null. So while current is not null, we're essentially going to keep iterating through the linked list. And with the operation that we're essentially going to do should reverse those references. And so here, what we want to consider is that just looking at the problem, a person who hasn't seen the solution would probably say, okay, well, let me take current's reference, right? This is current's reference. This kind of current's hand is reaching out to the next node in line. And so when you do current.next, you're referring to this hand, right? So if current.next if current.next is set to this, then current.next is referring to this guy. And so, you know, one could think, okay, let me take current.next and set it equal to previous, right? What would that do? Well, that'd probably reverse the first initial node. And they would be partly right, because if you did current.next, if you said current.next equals previous, you would effectively be reversing this initial node. But the problem is you would want to repeat the process, and you probably couldn't, because if you could, I mean, how would you do that, right? You've lost your touch with this node. This node doesn't have a reference that's attached to it. If we then wanted to say this node's hand, this node's reference equals current, how would we do that? It doesn't have a name. It doesn't have a reference attached to the actual object. So it then becomes apparent that before we do current.next equals previous, we should probably save the next node in line or the next object in line by creating a reference that will hold a sort of an attachment to the next node. So what we do is we begin by, we recognize this, and we essentially create another reference called next, which will be responsible for containing the next node in line. And we set that equal to null. And then on each and every iteration, since next is going to be something different each time, we say before we switch what current is, before we take current's hand and attach it to previous, what we're going to do is we're just going to say that next will equal current.next. In other words, what's next in line is essentially going to be saved in this reference called next, so that as we move on and take current's hand off from this node or this object, we're not going to lose track of it. So this is an inherent part of our algorithm. So as of now we can say that, you know, now we have this reference on next, so that as we move on and we bring current forward, we can we can allow it to refer to something. We have a handle on it. And so this is part of our algorithm here. And so from here, from this position, and let me go ahead and show you the initial position and where we are now. We had previous, before this all started, we had current, right? And I'm just showing you what the code was. And then we have next, and they were all pointing in this manner here, right? And then we said, we're going to iterate through the linked list, and we'll say that next equals current.next, which is where this came from. And then, well, now we're here, right? And this is not a different iteration. This is still the same iteration. I'm just showing you step by step what we've done with the code that we have here. So next equals current.next. So we've saved next, and current.next is previous. So we've taken current's hand and attached it to previous. And what do we want to do now? Clearly, this isn't the end of the algorithm, because if we keep repeating that behavior, if we didn't add anything else to the while loop, what would happen? Well, in the next iteration, next would be set to current.next, right? And current.next is null. It's null. Or current.next is previous, and previous is null. So next would be set to null, and that doesn't help us in any way to continue on with the algorithm. So that's probably not a good option. So clearly our algorithm is incomplete, and clearly we have to add something else to the algorithm. Now, intuitively looking at it again, we could think that perhaps now we can move current up, and or perhaps we could do next dot next, right? Or we can't say, there's really no way to say next. Well, we could say next dot next equals current, and perhaps that would take the hand off. But then we get to the same problem, which is, what would we do after we do that? After we do next dot next equals current, it points to current, but there, we can't advance next in any way, because now we don't have a handle on this node. We don't know what it is. We don't have any means to reference it by to reverse that last node. So next dot next equals current is probably not a good option. So perhaps intuitively then you could think that okay, let me move current up, right? Let me go ahead and take what current is and let me move it up one. And so you could say current equals next, right? Current equals next. So you could add that to your algorithm. Current equals next. That's probably a good idea, right? But the problem there is that then we take next hand, which is the reference, next reference, and then we do what with it, right? We can't, or since now current and next are the same thing, perhaps if we do current.next, we would still be referring to the same thing that next.next would be referring to, since current.next and next.next are both referring to the same thing. Their next would be the same as well. So, I mean, what would you do now? How would you take, okay, so you take current.next, right? You have its hand, and where do you point it? You want to point it in this direction? How would you do that? Again, you don't have a name for it. You don't have a reference that is attaching itself to this node. So that's essentially a problem. And in order to, so that's not going to work. So current here was probably better. And then we'll move from here now. And so the solution is that while doing current.next, while saying current equals next and moving current up to next is intuitive option. It's not going to particularly help you solve the problem per iteration. So what we do is we take what we have, and which is of course this, and we move previous up by 1, right? We move previous up by 1. So what we do is, instead of doing current equals next, we do current equals previous, or not current equals previous, but previous equals current. So previous equals current. So whatever previous was, it's now pointing to current. And so now previous and current are both on the same field, sort of. And then you can advance current. So then you can advance current. Then you can say current equals next. So our third step in the algorithm would be to, after previous now has a valid name, sort of, we can then advance current. And then we'll just repeat this process on the second iteration, and then it will fix itself. So we take what we have and we implement that into code. So we say previous equals current. We move current up. We move previous up to where current is, and then we say current will equal next. Then we move current up. And then if we repeat this process, the next time we repeat this process on the next iteration, it would have done the same thing to this node that we've done to this node or object. And I'll show you that here. This whole process is one iteration. And now when we move to the next iteration, we're essentially going to repeat the same thing. So it's going to say next equals current dot next. So we're going to take what we have again. Or actually, let me go ahead and take this. We're going to take what we have, and current is going to equal to, or we're going to save the next guy, right? So we're going to take the next guy and we're going to save it. So now we have a handle on this. And then we're going to say that current.next is previous. So its hand is now going to point here. And then we're going to move previous up with current. We're going to move previous up with current. And then we're going to move current up to next. And that ends another iteration. And then we'll do the same thing, right? So now we'll do the same thing to this object or this location in memory. And how that would look like would essentially be, we would save next. So we would say that next will equal current.next. So we'll say next. So next is now pointing to null. Okay, next is pointing to null. And then we say current.next is previous, right? And then we move previous up to current. So previous is now with current. And then we move current up. And now that current is null, it's not going to repeat this process again. And that ends that. But and the list is essentially reversed. But a question that I want to ask here to anyone who's viewing is that, now next is null, right? It's not pointing to anything. So how exactly, now that it's not pointing to anything, you could just change this parameter here and say that, null until next does not equal null why don't we essentially have that as a condition? Well, the thing is that, next would be null, and we wouldn't be able to change current to previous. We wouldn't do that part. So next would be null on one iteration. So that doesn't really make a lot of sense. But that's the basic idea. And if you're confused as to why, how we were able, so essentially you can see here in the code again that next equals current.next will equal previous. So current.next becomes null, and then previous moves up to current. Previous will move up to current. So previous changes. Previous now refers to the same thing that current refers to, but current.next is still null. So that doesn't change anything. That's just a small doubt that many people have with reversing a linked list, but that's the basic idea.